In the previous video, we have seen that the dissociation constant Ka of this acid is given by this expression. In another way, we can write H3O plus as H plus because H3O plus simply means that H plus is hydrated. So for simplicity, we write H3O plus as H plus. So this is the expression for the dissociation constant of the acid concerned. Now we can also write Ka in terms of the degree of dissociation alpha and the total molar concentration C. For that, we consider the dissociation of acetic acid, which is a weak acid. So it dissociates into CH3COO-, which is the acetate ion, and H+. Okay. Initially, the original concentration of acetic acid is C, and for the ions are respectively 0. Okay. Now this acid dissociates into CH3COO- and H+, and then an equilibrium is reached. Okay. So at equilibrium, the concentration of this acetic acid molecule is C into 1 - alpha. It will not be C, but it will be C into 1 - alpha if alpha is the degree of dissociation. And the concentrations of these ions at equilibrium are respectively C alpha, C alpha. So, what is the expression for the dissociation constant Ka? So therefore, Ka is the product of the concentration of the ions, divided by the concentration of the reactant, that is the acetic acid molecule. Okay. What is the concentration of the ions? CH3COO-, it is C alpha, into what is the concentration of H+ at equilibrium? It is C alpha, divided by C 1 - alpha, which is the concentration of the acetic molecule at equilibrium. Okay. So here we get C square into alpha square by C 1 - alpha. Alpha is the degree of dissociation of the weak acid. Okay. So here we have C alpha square by 1 - alpha. Now look here. Here we consider a weak acid, right? So for a weak acid, this 1 - alpha is very small because alpha is small. Sorry, I meant to say in this way that 1 - alpha can be taken as 1 because alpha is very small for a weak acid. So it can be taken as 1. So for a weak acid, 1 - alpha can be taken as 1 because alpha is small. Okay. So the expression Ka becomes, if this one can be taken as 1 because this is very small, then we have C alpha square. Okay. Or alpha is equal to the square root of Ka by C. Then if we have two weak acids of dissociation constants Ka1 and Ka2 at the same concentration C, then alpha 1 by alpha 2 is equal to root over Ka1 by Ka2, where alpha 1 is the degree of dissociation for the first weak acid and alpha 2 is for the second weak acid. Okay. And Ka1, Ka2 are the dissociation constants of the two weak acids respectively. I hope it is clear. Now furthermore, the degree of dissociation is nothing but the measure or a measure of the capacity of the acid to furnish hydrogen ions, and hence we can write this one as strength of one acid Ha1 by strength of another acid Ha2 equal to square root of Ka1 by Ka2. This one is nothing but alpha 1. At the same time, this one is alpha 2. Okay, so this is how we compare the relative strengths of weak acids. So remember this formula.